Okay. Now we can move into multiplying now that we know how to simplify, because before you multiply, you really want to simplify and it'll save you some trouble. Okay, so let's just go to basic fractions to remind you how to cancel factors out. So if I think about these two fractions, I can multiply straight across and get humongous numbers, no thanks, or I can simplify them before I multiply. So 25/30ths is actually could divide both of those by 5 and get 5/6. So it's the same as timesing 5/6. 36/10, I could divide both of those by 2 and get 18/5. Okay, and I could times those across, but still, I'm going to times 5 times 18 and 6 times 5, which is ridiculous because I could divide by 5 first because 5 goes into 5 once, 5 goes into 5 once, and I still can reduce 18/6 and get 18 divided by 6 is 3, 6 divided by 6 is 1, and my whole answer there is 3. All right, so I'm going to take this off and just kind of do it another way and see if we get, so I could divide 25 and 10 both by 5 and get 5 and 2. And I could divide 36 and 30 both by 6 and get 6 and 5. And it looks like I still have 5 divided by 5 or 30 divided by 10. If you want, you can just take 5 times 6 and 5 times 2, and you'll still get 3. So do you see, the more factors you can cancel out that divide to 1, the better are you off getting a simpler answer. All right, let's try this one. So I can look at 2 goes into 6, so 2 goes into 2 and once, and 6 3 times. And that's it. Now, remember, 1 needs to be in the numerator and 1 needs to be in the denominator in order to cancel ones. It has to be a factor in the numerator and a factor in the denominator. So like this 3 and 9 can't touch them. All right, so let's times up what's left. 3 times 9 is 27, and there's my answer. Okay, if I do get a whole number of any kind, I always put it over 1. And then it looks like I can cancel the 3 and the 15 and change that to a 1 and 5. And so I have 2 times 1 and 5 times 1. Okay, let's get to the algebra ones. Yeah, okay. Not sure why these multiplication signs are so bold, so I apologize. They look a little strange to me. Okay, so what we have are 2 terms, 2 terms, 2 terms, and 2 terms. So what you want to do is you want to think of this as one factor, this as one factor. Okay, so I'm going to just see, before I multiply anything, really, you can, as long as I take one factor from the numerator and one from the denominator, if they're the same, and z plus 8 is definitely the same as 8 plus z, that divides out to one whole. So I have 1 times 8 minus z, and 1 times z minus 8, which is just a little too corny, because remember our trick, if we take a -1 and factor that out of the 8 minus z right here, it becomes z minus 8. Got to remember that trick. And then this z minus 8, and now we have another 1. Those are both 1s because z minus 8 divided by z minus 8. And the answer is -1. The whole answer to that is -1. Now here the difference is, if I've lost any domain restrictions, I've got to list them. And there's nothing in here except -1. So I've got to go back to what I first canceled, which is right here. And there was a domain restriction right there. Z could not equal -8. And then I canceled these, which tells me that z could not equal +8, or the denominator is 0. So my answer is -1, but it's actually -1 comma z cannot equal 8 or -8. So this is my final answer. All right, let's do another one over here. So there's a little mixture, because this one on the top left, that's not factored yet. So that's one factor. these guys, there's no plus or minus over here, so that's a whole bunch. That's 46 times x to the fourth. So those are all freebies. Those are factored. I mean, those are all factors. And then this one over here is not factored because there's a minus in between them, okay? So can I factor this 1 minus 3xy? No, just keep it together because they are definitely together. And over here, 46 x to the fourth y squared really is just all them together. I have 4x squared y. And now this 15 minus 45, I know I can pull a 15 out, so I'm going to times 15, pull it out, 3 minus, sorry, that's not 3. 15 goes into 15, 1. And the reason I caught myself was because I think it's going to match with this one. 1 minus 3xy. And sure enough, now all I have is factors. Now see, all the pluses and minuses are inside parentheses, inside a factor, which means I can now cancel that and that. And, well, I can also cancel, let's get a little bit thinner, one of these y's with one of those y's, leaving a y, and 2 of those x's with 2 of those x's, leaving x squared. And what about the 4 and the 46? Yep, 2 goes into 4 and 2 goes into 46. Wow, this is getting messy. Here's what I recommend you do, guys. Write big on your homework because I don't want to miss any of these when I pull them down. So first of all, I'm going to highlight all the ones that are gone. I got this, wait, blue. So this one's gone, 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 gone. All right. So what's left is this one, this one, this one, and this one. Okay, so I don't know if I'm making it worse or not. I just want you to be careful that we don't miss any. So in the numerator, I have a 23x squared y. In the denominator, I have a 2 and a 15. 2 times 15 is 30. And that is my final answer. Now you say, but Marge, you canceled something. So here's the deal. In this textbooks, and in many textbooks, if you're canceling on a multivariable expression, that means there's more than one variable in it, you don't worry about the domain restrictions because it's not a function. So see how there's both an x and a y in this? I don't need to worry about, not to worry about the domain restrictions. Domain restrictions when more than one, that variable. Okay, and yeah, because you're not going to have a function with more than one variable. Okay, so multiplication steps are factor it, and then cancel. And we're going to do one last problem here on this video, and then we'll continue on. Okay, so let's take a peek at this problem. All right, so obviously nothing is factored. There's a bunch of pluses and minuses in there. So technically, this is one factor, this is one, this is one, and this is one. But those are not very good because all of those can be broken down into factors. So let's look at the first one and pull an x out of there, and then we're left with x minus 4. Now next to it is x squared minus 4x plus 4. That's a trinomial. So I'm going to change that into x times x, 2 times 2, minus minus. Okay, so that one went here, that one went here. Okay, that's all my numerator. All right, let's take a look at the denominator now. So x squared minus 4, that's the difference of 2 squares. That's x plus 2, x minus 2. So that one went there. Oh boy, this one's coming out here. Negative x squared minus x plus 20 is not okay because the first term is negative. I'm going to take the negative one out of there so I can factor it with ease. Okay, now that I have my nice neat 20, now that I have the -1 out, I can break this down. 5 times 4 is 20. One of those is negative. It's going to be on the 4 because I have a positive x. See why we spend so much time factoring? This is why, guys. Okay, so this guy is going to become -1 times x plus 5 times x minus 4. And that is here. Wow, this is a doozy. All right, can we cancel anything? This is the fun part. Yes, x minus 4 divided by x minus 4 is 1. And this x minus 2 divided by x minus 2 is 1. And that's about it. So let's take what's left. So I've got my x here and my x minus 2 in the numerator. And in the denominator, I have this x plus 2, this -1, and this x plus 5. So I have, I'm going to put the -1 in front. And I'm not going to put 1. I'm just going to write negative x plus 2 and x plus 5. And then I have to ask myself, did I cancel anything that I need to list as a domain restriction? Sure enough, I did. Let's go back to here at the beginning, right here, where I canceled those two. And that tells me that x cannot equal 2. I think that's all I canceled. So x cannot equal 2, because you can see right here that x cannot equal -2 or -5. We can see that, but we can't see the -2. Okay, final answer right there. Let's pause here, and you can work on the multiplication, or there's still division to come in the same section.